we started out, we talked about the console a little bit, right? We talked about the different kinds of things that we can do to like return stuff out. So we said the return is what allows us to take information or data from a function and pass it to the outer context. So we use that return keyword, right, when we were inside of our local execution context, and whenever we wanted to return whatever value we were getting out of there, we use that return keyword. And so when we do that, yeah, we can close that. Lost a few. Make some more space. So whenever we use that return keyword, it tells us, hey, I'm done with this function. This is the value that I want to store wherever I was trying to call that function, right? So the other thing that we have is the console log. And that's what we talked about over here, this little console. We haven't actually used it yet. We tried to use it before, but we got an error because we were trying to console log a variable that we didn't have access to. If you remember that in the very first slide. So basically here, we've got two functions. Well, we got one function, and then we're going to call it. So let's walk through how this function works so we can see kind of like how console log and the works. Let's get that here. So I'm going to make my console a little bigger now since I'm actually going to use it. So, all right. What is the first thing I'm going to do in this execution? Remind me of your name.
Diane.
Okay. First thing first line of code. What am I going to do?
Add a function, add
Uh-huh. Okay. Am I going to run this function right now?
No. You're just like declaring it.
Super. Exactly. So what's the next line of code?
So that's within the local execution context.
Mm-hmm.
I don't really know what console log means.
Well, we haven't gotten to that yet, right? Because that's inside this like definition, right? So right now we've just declared our function and put it in our global memory.
Yeah.
So what do we do next?
So we declare output.
Exactly. So output, and what are we setting that equal to?
The add function using 50 and 55.
Okay. So we're going to have to open up an execution context to do that, but what am I setting output equal to in the meantime?
Undefined.
Undefined, exactly. And that undefined is just like a placeholder, right? While I go over here and put add function on my call stack. And then I open up an execution context on local memory. Right? So, now I've called this function with 50 and 75. Diana, what's the first thing I do?
So in the local memory, we put num1 as 50.
Okay?
And then num2 is 75.
And how do you know that which one's which?
The order.
Exactly. So here we were doing before, we only had one parameter. Now we have two, separated by a comma. So now our parameters are num1, num2. So when we pass 50 and 75 in, we say num1 is 50, num2, 75. So now we go into our function. What happens inside of our function? We're going to console.log. Luckily, we don't have any loops in this function. So, what does that mean? Console log num1 plus num2.
So when I saw that other slide, it was like a print statement.
Exactly. It's exactly what it is. It's a print statement. In other languages, they actually use that word print. In, I'm not sure which ones. Maybe oh, there we go. So, in JavaScript, we use console log. And that's how we print something to our console, right? So, are we going to print? How are we going to print? What is actually going to get printed, Diana?
The sum of num1 and num2.
Exactly. We're going to do the sum of num1 plus num2. Because it's two different variable names, so we're going to say 50 plus 75 is 125, So we're going to console log 125. What's the next line of code?
The print statement output is, and then 125.
Yes. So we finished this execution context, right? We close this out. We pop this off of our call stack. We finished add function. Now we have console log output is output. Sorry, we skipped here. So what is output?
125.
Where did we say that?
Oh, actually,
It's outside the function.
it's not.
This is the trick. See, in here we didn't return
Yeah.
num1 plus num2. We just console logged it, right? So we printed 125 over here, but we never actually used that return keyword. So our function did some stuff, but it never actually returned a value. So when we get to the end of the function, this execution context gets closed out, but output is still undefined because we never returned a value from our function. So now we're going to say output is, and literally we'll just say undefined, because the value of output is undefined. Because we declared it, but we never actually gave it a value. And we have to use that return keyword inside of our function to pass that value back out. So how could we change this? What would we change inside of our function so that output actually gets stored as 125? Yes?
Return.
Exactly. We would change console log to return. And if we just said return num1 plus num2, then that would be the last thing that would happen. We wouldn't ever actually console log 125. We would have returned it out. We would have set output equal to 125. And then when we console logged output is, we would get 125. So that's the difference in the return versus console log. If you don't return anything out of a function, the function can still run. It just doesn't return anything, you know? So it doesn't evaluate to a value. Yes, Mike.
What's the type of undefined?
So undefined is a data type. It's a type of its own. So there's 6 primitive data types in JavaScript. You have strings, numbers, booleans, null, undefined, and something called symbol, which I don't know anybody that's ever actually used. It was kind of created with ES6 and then quickly got downgraded and pretty much obsolete. So the 5 that you'll use on a regular basis are strings, numbers, booleans, undefined, and null. And while undefined and null may seem like the same thing, they're not. So undefined literally means it's undefined. We haven't given it a value. Null is a value in and of itself that is just null. Like this value is like null. It's just void of a value.
So null is definable. You can make something null.
Yes.
Yeah.
You can make something undefined. You can set something equal to undefined, which is what we do under the hood here, which is why when we declare an output but don't give it a value, it is undefined.
Is it null when like you return something that is wrong? For example, going back to what we were talking about earlier, if you call the length property on an integer, it's going to return null.
No, you'll actually get an error.
You're gonna,
Because it'll say that
you
like
can't
length property does not exist, so it would just error.
Is null like atheism? Like there is no God, whereas agnosticism? We don't know. We are not.
Sure. If that's how you want to think about it.
We don't know.
Scratching that analysis.
So null, we'll just say null's kind of like the black hole. It's like it exists, but there's nothing there. It's just this empty value, right?
It's an empty.
It's a theory. Exactly. Yes.
Yeah, my question. I noticed sometimes people pass empty strings.
Yeah,
That's kind of the same as null.
It's not the same as null. An empty string is a string. It's just empty,
Okay.
right? So, and that's different than null.
Okay.
So null is a value in and of itself. Yeah. Yes.
So you could in this with the parameters you have right now, you could assign the two to be null, right? To say like
Yes, you could.
if you want, yeah.
Yeah. I mean, if you pass null in as the number, then yes.
Right.
Then num2 becomes null. You could pass in num2 as an array, but then if you try and add an array and a number, then
Right, you wouldn't be.
it gets a little messy. That comes into all type coercion and whatnot, which is a whole other bag of worms. So does that make sense though? Console log versus return? Thumbs up on that? So this is going to probably be the last thing that we cover. There's a couple slides after this which are about kind of iterating through objects, which we may not have time for, but I'll try and like briefly go over them. But objects, as it says right there, and I think I said at the beginning, are the backbone of JavaScript. All data is an object. All of our primitive data types, strings, numbers, everything is an object at the end of the day, right? But we also have data types, objects, which, like arrays we saw before, which are like a list. And if you guys are familiar with Python, I think you actually use that as well. But an object, we know it's an object because we use these curly braces. So we're declaring a constant person, and we're setting it equal to this object. So an object is basically, it's one of our two composite data types. So you have the 6 primitive data types, which I mentioned, which are all immutable, which basically means you can reassign the whole value, but you can't change individual pieces of them. Whereas arrays and objects are our two composite data types in JavaScript, and they are mutable. So in here, if I wanted to change my fav num from 17 to 3, I can do that, right? Because that's just one piece of my object. So mutable versus immutable just basically means whether you can mutate something or not. So an object or an array, I can change the contents of the object or the array. But I can't necessarily, like with a string, I could reassign the string to another string or to another data type if it's not a const. But I can't like just change one letter in a string without reassigning the entire string. Does that make sense? Like if you have the number like 100, I can't change like the first 0 to 1. I would have to reassign the whole number to 110. I can't just be like, change the second digit to 1. It doesn't work that way. The number is immutable, and it's all or none. So I can reassign its value, but I can't change individual pieces. With objects and arrays, I can change the individual pieces. They're mutable. We can mutate them. Okay? So objects are made up of key value pairs. So let's just keep in tune with our execution context here, but we're going to make this bigger. And I'm going to make my console here. Okay, so the first thing I'm doing here, call. First line of code on this page.
So you're declaring this object?
Yep.
Person?
And I'm setting it equal to this object, right?
Yeah.
So what do all these different things mean? Like what is name?
That's the first key?
Exactly, it's a key. So as I said, objects made up of key value pairs. So a key is whatever's to the left of the semicolon. And that's basically, it's almost just like a variable inside of a variable, right? So you're saying, within person, I've got this other little variable called called name, and its value is will. But all of this stuff is stored inside of person. So we're going to write it all out here. So name, and I put my colons, and it's will. What's the data type of will? Exactly. And how do I know that? Quotation marks. So the next thing, I move to the next key value pair with a comma. All of my key value pairs are separated by a comma. Now you could put all this on one line if you want. That's just really messy. And it's much easier to read if you just break it down. You put all your key value pairs on separate lines, just like this. That's the biggest thing about writing code, is you want it to be as readable as possible. So even if you're like, oh, I know where it is. You know, it's kind of like if your room is a complete mess, you might know where everything is, but if you need to tell somebody else how to get into your room and find something, it might be a bit of a task to dig through all your junk to find the one thing. I'll get you 1 second. So that's why you want to make sure that everything is organized. The more organized you can make your code, because very little code that you write is just for you. There's always going to be other people adding to it, working with it. So it's very important from the get-go to just get in the habit of structuring your code in the most readable way possible. So when it comes to objects, we like to do this. We like to put each key value pair on a separate line delineated by a comma to go between them. Marcus,
I was
question?
just going to say, because when I first started reading about JavaScript,
Mhm.
you write code for other people, not for yourself.
Exactly.
Because other people have to read it.
Exactly. And one of the things that we do here in our program, our first group project that you do is called a Scratch project. And that's where your group creates something from scratch. So you have 3 days to build an application from start to finish. Then our next project is called the iteration project, where you get a new group, and then you have to basically take one of those projects that one of the other groups created in the first 3 days, and you have to iterate on it and add to it. And that's when everybody learns the importance of writing clean code. Because when you get somebody else's code and you've got to be like, man, what the hell were they trying to do here? When you get somebody's code that's really clean and easy to read, you're like, oh, this is great. Okay, we can do this, we can do this. But you might get that code and it's such a mess that you spend 3 days just trying to figure out what all's going on and organize it. And then you're just like, oh shit, what do we do now? Right? That's no good. So organization is key in programming. And I like that. I like that quote. You write code for other people.
Regarding on that, if it's like unreadable, meaning like if the organization is really bad, can you go to the original person or original developer to explain what's going on?
Well, what if they don't work there anymore?
Also, you mean it like that?
You know, it's just, you get handed a set of code. I mean, you go work for a company, you might work for a company like Google and you can be pretty much assured that every line of code is going to be pretty pristine. But you might go work at some startup that had some guy that didn't know what the hell he was doing, writing a bunch of code, and then he quit or got fired or, who knows. And then so they hired you to come in and fix all the stuff that he did. You're going to learn real fast how much of a pain in the butt that can be. So that's why it's best to always write your code as clean and orderly as possible so that whoever else is going to take over it after you, because you're going to have a job, you're not going to be there for the rest of your life probably. This isn't the 30s anymore. We don't get one job and work there for our whole life. Most people bounce around to different jobs throughout their career. So, whatever code you write, somebody else is going to work on it after you. And you're also working on a team. So the people that are sitting at the cubicle next to you or in the office around the corner are also working on the same code. So if they keep having to come over and be like, dude, seriously, I can't read any of your code, you're probably not going to work there very long. Right? So think about it like that. So back to our objects. So the next thing, company, is another string. Not name, we already did name. Codesmith. What's next?
Favorite number.
Fave num. And how do we know that that's an integer? It's not. It's a number. You're right. But what if I put parentheses? Or what if I put quotes around that number? Then it would be a string. So we know it's a number because it's a number and it doesn't have parentheses or quotes around it. So it is an integer or a number. We call it in JavaScript. So next, has red hair. What's this one? A Boolean. And what is a Boolean?
True or false.
True or false. Only two possible values that you can have as a Boolean. And how do we know it's a Boolean and not a string? No quotation marks. Exactly. Next line, we've got fave snacks. What is this one?
An array.
Exactly. It is an array of strings.
Yeah.
So we've got twin snakes, which I found out apparently is some kind of gummy worm or something like that in one of these classes. I've never heard of a twin snake. Somebody looked it up on the internet. Will's from the UK, so maybe it's a British thing.
It
Is it? Yeah, okay, there we go. So we've got twin snakes and gummy bears. What's the next thing?
Greetings is a function.
Next is greeting. And this is a function, right? Console log. I'm just gonna say.
Would you have said my function or something, or did you have to use the word function there?
If you said my function, then you would have had to have declared my function somewhere else. So here we're declaring a function, and I'll go into basically what that means here in just 1 second. And then that is our last thing. So we don't use a comma on the last one because just like a sentence, you only put commas. You don't put a comma at the end, you put a period. So we close out the greeting, and then we close out our the object. So, as I said, all of these key value pairs, now you've seen the key is always the key, right? But the value can be anything. And this is why this is a composite data type, because it's built up of any of our primitive data types or other composite data types. So strings, numbers, and booleans, primitive, exactly. But the array is a composite, okay? So, but we can also have functions here. So when we say greeting is a function that does this thing, that's basically the same as like before when we would say function greeting and it does like stuff, right? So this is the exact same thing. So instead of saying function greeting and declaring this function, we're giving a key and we're saying, okay, function or greeting is equal to this function. So it's the exact same thing that we're doing, but inside of this object, we name it differently, right? So how do I access Will?
Person.name.
What's that?
Person.name.
Person.name, exactly. So the next line of code, console.log, person.name. So what does that mean? What am I going to write in my console? What's going to get printed
Will.
to the console? Exactly. So line 1, we've printed Will. Next line.
17.
17.
What would be an error? No.
Why would it be an error message?
Because favenum is not a string.
So this is where it gets interesting. So all of our keys,
There.
they are strings. Exactly. So basically we could say person.favenum, or we can use the bracket notation. So it's two different ways of accessing information within our objects. We have the dot notation and we have bracket notation. So just like we used the bracket notation in our array to get the index, here we're using bracket notation to get a key value pair.
Does the bracket notation require the string? I mean the quote.
Require the,
Quote.
if you want, okay, so if I just said favenum, then it's looking for a variable, favenum, right? But I don't have a variable favenum. It doesn't exist.
Could you say person bracket 3? You get the same?
No. Because this isn't an array, it's an object. So the only way to access any of these values is by its key. Just like opening a door, you have to have the right key. So if I want to get to what the value of has red hair is, I've got to get the key has red hair to return that value. Yes?
Did you say basically that you can call the property by, say, person.name or person and name inside square brackets?
Inside the square brackets, but if you use name inside the square brackets, it has to be in quotes, right? Because you have to pass the string, right? Well, we'll get to, let's say I have this person here, right? And then I also declare a variable called const property, or prop equals the string fave num. So now, so if I got, okay, if I want to get to fave num, I can say person dot fave num, which equals 17. I've got person bracket the string fave num, which will evaluate 17. But now I've said that prop equals the string fave num. So now I can still use my bracket. And I can say bracket prop, because prop evaluates to the string fave num, right? So when I say prop, and I don't have quotation marks around it, then it knows that I'm looking for a variable. So when I say prop, where do I go to find out, where do I go to look for prop? In my global memory. So I come over here and I'm like, okay, I've got person, this is that, oh, I've got prop. So prop equals the string fave num. So this essentially evaluates to this. So now prop is the string fave num. So I can either say the string fave num. Your question was, can I say person.prop? You could, but it's going to say undefined, because prop is not actually a keyword in here. So if you want to use a variable name or a string, you have to use the bracket notation. If you use dot notation, it has to actually be a key. So fave num is a key, right? But prop isn't actually a key. Fave num is the key. But prop evaluates to the string fave num. So if you want to use a variable name inside your to get a key, then you pass it through with the bracket notation. Yes?
Can we add a new key outside the object?
Outside of the object? No. So key value pairs only live inside of an object. But let's say,
But then where did you define prop equals fave num? Is that outside of the object?
yes, that was a hypothetical that because he was asking about the difference, why do you pass a string? So this was just something that I added. It's not anything on the board. So basically that would be like saying if I above const person I said const prop equals fave num, like the string, then it would be down here in my global memory. It's not something we actually did, so we will just forget that for now. So what if I've got fave num, what if I want to add Will's favorite city? Like we'll say I want to add a key fave city. How do I go about doing that? How can I add something to this object person? So I know how to access something. Dylan?
I think it's you type in person and then bracket notation whatever the key you wanted to use and set it equal to the value you wanted it to be.
Exactly. So you can do the bracket notation or dot notation. So let's say I want to add fave city. So I can say person dot fave city equals NYC, put that as a string. If I wanted to do it in bracket notation, how would I do it? Exactly, you gotta put it in quotes. Not giddy, city. Equals NYC. So either one of these things would have us come back into here, and at the bottom of our object, we would say, comma, fave city equals NYC. And then we would close out our object here. So this is how we can access something, or we can also add something. So I don't have to say like, in person, declare this variable fave city. I just say person.favecity equals NYC. So if it exists, 1 second. So if I said person.favenum equals 3, It's not going to add something to the bottom, right? Because favenum already exists in my object, right? So what's it going to do? It's going to change its value. Exactly. So if I called person dot favenum equals 3, it's going to come over here. It's going to be like looking for, oh, found favenum. We're going to set it equal to 3. In these cases, it's going to say person.favecity equals NYC. It's going to come over here. It's going to be like, no, I don't have this. Okay, I'm going to add it to the bottom. Favecity equals NYC. So this is kind of how objects work. Now the next thing, console log person.favesnacks.
But it's actually
Gotta-
0.
gotta get the first.
That bracket 0, exactly. So we've got Will now. We've got 17.
It's gonna be a twin snakes.
Twin snakes.
Such a weird name for
I hope there's only 2 of them in there. Okay, next, now we're not saying console log person.greeting. We're saying, we're calling the function, right? So what happens?
It's gonna
Hello,
be console
everybody.
log.
Well, what do we do when we call a function? We gotta put on the call stack. Who said that? Ian? Exactly. So we're gonna put, what's our name? Greeting. So person.greeting, which opens up a local execution context. Greeting does not take a parameter, so we don't save anything. We go into it, we just say console log hello everybody. So that goes down here. We say hello everybody. And then we get to the end of our function. So we close out this context. We pop that off the top. And we've finished. Right? So if I said, let's just say I added something to the very bottom line. The next line says console log greeting. What's going to happen? You think it's going to be an error?
Isn't that just how to check it?
Hmm?
Isn't that what you call check, like how to check it when you console log after you
We just
call
say
the function?
So, but I mean, a function, I could call a function 100 times if I wanted to,
Yeah.
right? So here, if I'm just saying console log, just greeting,
You're just gonna show a greeting.
Function definition.
the function definition, exactly. So greeting equals this. So when I say console log greeting, I'm literally going to get function console.log and then close out.
But it would have to be person.greeting, wouldn't it?
Yes, sorry.
Okay.
Some error.
Is that there's just greeting?
I am just a person as well who make mistakes apparently.
So we put greeting in the console.
So yes, you were right. Sorry. Console log person dot greeting.
Greeting. Yeah.
Because just greeting would be an error message.
Just greeting would be an error message, because greeting doesn't exist. So we have person dot greeting. Good catch. Who called that? Colin?
Why would it just be greeting?
So,
Oh, no,
put
but
an
greeting
extra
is not
parenthesis
it's not
after
called
greeting?
string.
What's that?
An extra parenthesis
Then it'll say
after greeting?
greeting in the console.
So when I say that's the point of this. So if I say person dot greeting,
Go into greeting.
Oh, that's what you're, okay.
that's what I do, right? But now let's say now what do I get?
Hello, everybody.
That's an error.
So I believe you would actually get undefined because the function doesn't actually return anything, right? So it just says undefined. So when we use these quotations, open and close parentheses, not quotations, parentheses, that means we call the function. So without this, This means the actual definition of the function. But anytime you see that after a function name, just said that means go. So that means run the function and give me whatever comes out. But in this, we didn't return anything, so nothing comes out.
Would it log it in the process of checking?
It would log it.
Okay.
Yes.
Okay.
So we'll log it, but it won't return anything here.
Wait, I don't, if you call the function person.reading, why, in the object it says console.log below, so why would it print that?
So that's what I said. It would print that, but not from this console log. This console log, so you're going to basically, so what's going to happen is, so you're going to say console log person.greeting. So it's going to run this function, which will print hello, everybody. So that's that console log. But now this console log is printing what evaluates from here, which is nothing. Undefined.
Can you explain the two console logs?
Well, it's like because one is within the other. So
Yeah.
the first one always goes first, which is console log hello world, and then when you do it again, that's undefined because you're like trying to.
Yeah, but my question is, can you explain the two console logs? I didn't realize there were two.
Yeah. So here we're console logging the output of person.greeting, right? So this is one thing.
Yeah.
So this is operating in our global execution context. But when we run person.greeting, we actually open up an execution context.
It has its own console log?
Yes. And then inside of this function, what we do is console log hello everybody. So this one runs,
Yeah.
prints hello everybody. The function gets closed out, pops off the call stack, but this we still have to console log something, but this evaluated to undefined because we didn't actually return anything. So now undefined gets printed underneath. So this one runs when we run the function in that context because we put that on top of the call stack.
Yeah.
Once we finish running that function, we pop out, but we still have to finish what we were working on.
So you have to say console.log person.function with the parentheses.
So if you put those open and close parentheses after, that means you're running the function. Without that, you're just returning the definition of the function, which is function equals console log hello everybody. So that's the difference.
But there is no function person.greeting because we didn't establish a person.greeting.
Person.greeting's right here.
What I'm saying with the parentheses though.
Because it doesn't have a return, it just has a print.
Yeah, so it is a function, but it just doesn't return anything. Right? So it does things, but it doesn't actually do anything. So if we change this console log here, like we did before, to return, right? So instead of console logging hello everybody, we return it. Then we only have to actually console log one time. Because this returns hello everybody, which goes up here. So it would console log hello everybody, we'd never actually do undefined. Because now there's only one console log, right?
Right.
And this goes into, if you add, you run a function inside of a function inside of a function, you just keep adding to the call stack. So you could have like a lot of console logs all happening in one time. But it's just goes on top, whenever you finish that, pops it off, and then it goes back and finishes what's underneath it. And that's what you just have to get in the habit of, that execution context. Just think about that call stack. JavaScript can only do one thing at a time, and it's always only working on what's on top of the call stack. If you're in the middle of doing something, and you add something to the call stack, it's going to finish what you add onto the call stack before it goes back and finishes what you were already working on. So think of it just like you're at work and you're trying to get something done, and somebody keeps coming in, hey, can you do this? And you're like, so you go over here and do this. And then you go back and you're trying to finish what you're doing. They're like, hey, can you do this? So you have to go over here and do this. You can only do one thing at a time. It's always whatever's on top of your call stack.
Work never gets done.
Exactly.
I
Yes.
just wonder, if you add a lot of like keys and values to your object, is there just a way to call it? Just to see like how many different keys we have in that object?
Yes, there is. How can we loop over objects? to see all key value pairs one at a time. So there's a couple of different ways, and we are over time, so if anybody's got to go, it's totally fine, but I'm just going to fly through these. I'm not going to whiteboard them out, but I'm just going to kind of show you, and you can write down what it is, and you can kind of look it up later. But there's two different ways. So first, we have our object still. We have this for loop down here, right? So it says for let key in person. So what that means is we're going to create a loop. But basically for let key in person, so we say let key equal or in person. So basically this creates an array for us of
all the keys in that person.
Name, company, favnum, and it does this under the hood, basically, and it just iterates through. So it'll go to, so what happens is console log current key, key. So it basically just goes through and prints out each key, every key. So the other way to do this, so everybody, you can write this down, a for in loop. If you just type that into MDN or W3 schools or wherever it is, you get kind of an explanation. But that's the old school way. The new school way with ES6 brings in object.keys and object.values. And this is what we try and use mostly in production these days. So object.keys, so what do we say here? Where do we do it? I'm not going to go through the whole loop. So, but basically if we say like object.keys person, and what that evaluates to is name, company,
As an array.
as an array of strings. Favnum, ... Right? So what do you think object.values does?
Pick the values of each one of those.
In what format?
In format that shows whatever the values with the keys. Key value, key value. Right.
But if we're doing object.keys, we only get the keys. So object.values, what do you think that is? Only the values. So object.values person is going to return an array that's will. Codesmith. Three. True. And then this will be the array. And then the function. Right? So you have object.keys, object.values. And those create an array of either the keys or the values. Once you have that, you can use one of your loops. You can use that for loop and iterate through. Setting it equal to 0, because name is at index 0, company is at index 1, favnum is at index 3. So this is how we go through when you were asking before if you do 3. You can't say person.3, but you can say object.keys person bracket 3. You're going to get has red hair.
In a nutshell, the benefit of objects.
Oh, that's a question.
I thought you would say something else too.
I was like, tell us, what is it? The benefit of objects is that it gives you a way to store a lot of different types of information. But unlike an array, so an array, if you need to get like the fourth thing, like maybe you don't know where in the array that is, right? So you literally have to start at the beginning and be like, is it this one? No. Is it this one? No. Is it this one? So if you just want to get, this person's fave number, it's like that. It's constant. So when you'll get into, as you learn more about coding, you'll get into time complexity and space complexity, where you know how long it takes to do something, right? If you've ever seen like big O notation, or if you've ever done like a leak code problem or code wars or anything like that, and you see like O with a little number next to it, or O of n, that's like talking about how long it takes to do something. And that I could literally give an hour-long lecture on big O notation, so we won't go into that today. But basically, it's another thing about making your code as clean and fast as possible. Because we live in a world today, like, no, if you go to a website and it's like not loading, you're gonna be like, no, next one. Like you're in like Google and you click on one, you're like, not loading, back, and you're gonna go to the next thing, right? We have no patience whatsoever anymore. We want everything like this. So when we're writing our programs, we want them to access that information as fast as possible. So with an object, we have a constant time lookup. So if I want to know Will's favorite number, or fave num, I person.favenum. It's there.